Show you guys how to do problem 33 on a calculator that is not clunky. So here you have my TI-84 Plus. And we're going to go into the y equals menu, and we're going to type in, I'm going to clear this, I'm going to type it in one more time so you can see it in action. 1 plus x squared, comma, parentheses, 1.1 divided by x squared, parentheses, enter. So I'm just gonna only graph one of these guys. And I already have the window set to the first setting. So in problem 33, we're asked to graph the window between -1 and 1, and then 2.5 and 3.5, and then use the trace feature. And so notice y is undefined at x equals 0, but if we get really close to it, we're at 3 and 3.034. So
I have a question on numbers.
So we're getting closer and closer to 3.03 as we use the trace feature. Now, the problem now asks us to adjust the window to -0.001 to 0.001, and our y value and our y-axis to stay the same. So we're going to graph it on a closer interval, and we get what looks to be a straight line. So now we're going to use the trace feature again. Again, we are undefined at y. We are at 3.004 and 3.004. So now let's look at when we go closer. I'm going to go into the window again, and I'm looking at -0.1, 2, 3, 4, 5 zeros. Nope, not negative. 0.02345 zeros. And we're going to graph even closer. Oh, well, this is interesting. Using the trace feature, y is 1, y is 1. Did I do this right? It's max x min 3.5. Trace at x equals 0, y equals nothing. All right, so that's problem C. Let's go on to problem D. So later we'll be able to show that the limit equals 0.30041. 6602 approximately. So what flaw do your graphs reveal about using numerical evidence as revealed by the graphs you obtain to make conjectures about limits? Well, we weren't expecting it to look this crazy when we zoomed in this far. In fact, when we zoom in this far, we don't get a nice answer. So that, my friends, is problem 33.